Okay, so this is my code, and how it works is first it reads the data from the CSV and it puts it all into a single um, or a single array. And then we don't get to this function yet. First, we go down to this function because that function gets called twice because we made two graphs. Or I made two graphs. So we initialize a bunch of arrays to be blank, and then we go over a for loop, and there's 6 iterations of it. Um, and then for each iteration, it calls this return scores function. And what that does is it shuffles the data and splits it up into x and y, and then it uses a label encoder because some of the data is characters, alphabetical characters, so they need to be numbers. That's what that does. Um, and then splits it into training and testing data, and then here are the 6 classifiers. So there's these are just all of them, and then the parameters are for the grid search. So I'm not going to go over every single one of them because they're just classifiers. They're pretty simple. But basically how I'm going to use this one as an example. And basically how it works is um, if I'm not using a different kind of method like bagging or boosting or grid search, which is what I was using, then it's just going to use the default hyperparameters um, for the classifier. Otherwise, in my case, I'm using different parameters because I'm using the grid search. If otherwise, I'd have to change this to support an ensemble method. But basically, the grid search is just it tries all of these different hyperparameters until it finds the best one, and then it's going to use that and fit the data on that. Um, so so that's the SVM, and then there's one for Gaussian Bayes, and then there's the 4 other ones, and that's the rest of the function. And at the end of the function, it returns all the scores that it found. Um, yeah, so it fits it, it scores it, it returns the scores, and then we go back down here, and the scores all get added to in this makegraph function to these arrays, and then I find the averages of the scores um, with this function, and then I add them to another array, and these are just the indexes of the array. So like SVM was the first one, so it's at index 0, and then and so on and so forth. And then I use that to find out what the um, what the classifier was with the highest average. It just iterates over it and then finds the index and then prints that out, um, which is shown here. Um, so this is the base classifiers. Remember this gets called twice. So the makegraph function gets called twice, and the base classifiers were just the classifiers that I didn't use the grid search on. So these are the scores for all of them for each iteration. Um, that gets printed in the other function, so that's within this loop. And then at the end of it, when it does all the averages, it shows you that the random forest was the one in this case that had the highest average score. Um, and then after that part, it goes in and finds it has to rearrange the data a little bit, just because of how this particular graph works. It's not actually changing anything. Um, but this is just how this is the graphing, uh, the So, and what that looks like is this. This is the first one. This is the base classifiers. So it goes from 0 to 6 because um, basically each one of these blocks is one iteration, and at and the maximum that score that an iteration can have is 1, because that would be 100% accuracy. So since there's 6 iterations, it goes up to 6, and then it just stacks on top of each other. So you can see the total score. And so for the first iteration, which these numbers are backwards, but that doesn't really matter. This is the first iteration of the SVM right here. You can see it's 0.93, and then this is the second one, 0.92, and so on and so forth. And then, but basically what this graph is showing is like how consistent each one of these classifiers is, and all of them are pretty consistent. Some of them are a little bit less than others. It's kind of hard to tell, but some of these blocks are smaller than others. Particularly for the quadratic discriminant analysis, it has 3 blocks that are pretty small, and that corresponds to these very low scores. So this classifier is really inconsistent on this data set. It would be a really bad classifier to use. If I was using this in the real world to figure out seismic bump activity. And this second graph it's basically the same thing, but this time I'm using the grid search algorithm. And so what you can see here is it's difficult to tell, but all of these are slightly bigger. So if I swap between them, you can sort of see that it raises a little bit. So these are a little bit better at figuring out what classification to give everything. Particularly, again, the quadratic discriminant analysis. Wrong graph. So yeah, this one is a lot better. So it's gotten more consistent. It's still not as consistent. This one's a little bit small. That's the 0.62. So it's not the best. Still not the best. And we can see that the random forest is still the best classifier between using the grid search and not using grid search. So this is not grid search. This is grid search. It's pretty close. The neural network is pretty close, but the random forest is still just a tiny bit better. And so yeah, that's basically it. This is just, again, this is the code that prints out all of the graph data. And down here we can see this is where I'm calling those 2 functions. You can pass different things into the method function. The way I wrote the code right now, it would break if you put an ensemble method in there. But I was testing it before, where I was putting in bagging for the method. So I was using bagging on all of them. But I didn't want to do that for the final result because we had a homework assignment on that already, and I didn't think that was different enough. But if I were to continue this in the future, then I think that it would be beneficial to definitely have some sort of ensemble method. I don't know if I would use bagging or boosting, but I think that would be important. And there was another project that was very similar to this, and the person that did it, it was also on the seismic bumps data, and he also trained a bunch of classifiers. But instead of using an ensemble method or grid search or anything like that, he did oversampling, because a lot of the data, almost very few instances of the data point to an actual seismic bump. So when he overfit the data, it was actually more accurate. um, uh, because of the low amount of seismic bump classification. Um, and also, I forgot to mention this before. So I showed you this one earlier. This is the random forest for without any grid search. And then at the end, we can see that the random forest with the grid search, that's what this is a little bit better. So even though it's hard to tell in the graph, you can see in the numbers. So there, yeah, that's about it. Thanks for watching.